My dear students, other viewers and listeners, you are welcome to this lecture on Introduction to Artificial Intelligence by me, Professor Manohar Lal, School of Computer and Information Sciences. Friends, today we will discuss a number of issues about the elementary aspects of artificial intelligence. A number of topics which we will discuss may be looked at from the slide. First of all, we will discuss how the name artificial intelligence, which is popularly known as AI, was coined. And then we will tell what is artificial intelligence. In this respect, we will discuss a number of definitions. Then the question arises, why artificial intelligence? Friends, we know the most popular method in computer science is algorithmic methods. That is, whenever we talk of solution of a problem through the use of computers, generally we think that an algorithmic method is used. However, as we'll see later on, the algorithmic methods are not sufficient by themselves in solving every type of problems, and therefore we have to seek alternatives, and AI or artificial intelligence provides an alternative group of methods by which we can solve an extra set of problems which otherwise could not have been solved with the help of only algorithmic methods. Then friends, as we know, every discipline has its own special techniques. So does the artificial intelligence discipline also. The three major techniques apart from some minor techniques are: number one, search is a very important technique which is applied in artificial intelligence. Then the use of knowledge in solving problems, and third is abstraction. We'll discuss each of these techniques in some details. Then, as we know, in every discipline there may be a group of leading ideas or paradigms. So in artificial intelligence is also, there are two major ideas or the streams of thought which are followed in solving problems within the tools and techniques of artificial intelligence. So we'll discuss briefly each of these alternative paradigm in order to make the discussion complete. Then friends, further we'll discuss there are actually two major paradigms. One is called symbolic paradigm and the other is called neural paradigm. So first of all we'll discuss the symbolic paradigm, and every paradigm has some of its fundamental assumptions, like Newton's laws of motion are there. Similarly, the symbolic paradigm has its some assumptions which is called hypothesis of symbolic paradigm, which we will discuss next. Then, as I mentioned, that search is one of the most important techniques of artificial intelligence. There are a number of search techniques within the search, and we'll discuss some of the major search techniques which are applied within artificial intelligence in order to solve problems. Then friends, as I mentioned earlier also, that the second major technique of artificial intelligence is knowledge. That is, there are a number of problems which may not be solvable otherwise, but if we have sufficient knowledge of the domain of the problems under consideration, then we may be able to solve the problems. And in order to exploit the knowledge of the domain of the problem under consideration, we need to embed the knowledge in a format which is acceptable by the computer system. So we'll discuss various representational techniques which are used to represent knowledge, particularly for solving problems from artificial intelligence point of view. As we know that computers actually solve problems when they are given a sort of program in some programming language. So there are a number of programming languages we know. For algorithmic methods, C, etc. are very well known programming languages. However, because AI is specialized discipline of computer science, in which special emphasis is on knowledge, exploitation of knowledge in order to solve problems. Therefore, we have to have some special programming languages which are good from the search point of view, which are good from the exploitation of knowledge point of view, etc., etc., which are good from the point of view of abstraction, which are the three major techniques of artificial intelligence. So these two programming languages, which are generally known, are Lisp and Prolog, and we'll discuss the very few important aspects of these two programming languages. And finally, we'll discuss some of the AI technologies if time permits. And the discussion of artificial intelligence is generally thought of as to be incomplete until unless we discuss the Turing test. So friends, this is a list of the topics which possibly we will be able to cover in these two lectures. So let us make a beginning how the name AI was coined. Actually, there was a conference in 1956 at Dartmouth College. At that time it was Dartmouth College, and in that 10 people participated who were quite young, brilliant mathematicians, computer scientists, and some of them were already well known. However, now if we see in retrospect, these 10 people are sort of founding fathers of the discipline of artificial intelligence, and out of these two, especially the first two which I'll just now name, are said to be the pioneer or almost whole of existing state of art artificial intelligence is owed to these two people or their students or students. So let us have a look at those people who actually started the discipline of artificial intelligence in 1956. Please look at the slide. The Dartmouth conference was held in 1956, and 10 participants, especially the first two, Johann McCarthy and Marvin Minsky, are the leaders of current artificial intelligence. Apart from them, Nathaniel Rochester, Claude Shannon, etc., etc., took part. Out of this, I may mention Claude Shannon is known as father of modern communication systems. Neville and Simon are also thought of as have made very major contribution to artificial intelligence. Even Herbert Simon, though a computer scientist, have been awarded Nobel Prize also. So friends, these are the 10 people who held a conference in 1956 at Dartmouth College, and the name was artificial intelligence for the discipline which they intended to generate was given by Johann McCarthy. In this context, it will not be out of place to mention that Raj Reddy, again a Turing awardee, has also made significant contribution to the discipline of artificial intelligence. His hearsay speech understanding system is very well known. Friends, in this context, I have mentioned that Raj Reddy is a Turing awardee. What is a Turing award? I may explain briefly, because we in computer science at least should know some of the major awards, etc. So Turing award is an award which is almost equivalent to Nobel Prize in, say, in the discipline of physics or chemistry. That is, it is annually given to a person whose contributions in computer science are adjusted to be the best in the previous years. And as I mentioned, Raj Reddy is one of those people. He was awarded this Turing Award in 1991. The Turing Award was instituted in 1968. Our discussion about Turing Award will be incomplete until unless I say a few words about Turing himself. Turing has been one of the best computer scientists so far. We can say within a couple of leading computer scientists whose contributions will be always remembered, Turing was one of them, and he is said to have won the war by decoding or deciphering the German code also. But apart from that, during 1930 and 1940, Turing, along with 5 or 6 young brilliant mathematicians, computer scientists, all in the age group of 25 to 30, had done another very important significant work in computer science, and that is about what computer science cannot do. Actually, during the period of 1930 and 1940, Turing and a number of others, including Gödel, etc., they proved that howsoever state-of-art computer system may be designed and developed, it will not be able to solve even a small fraction of the problems which the humanity may encounter ever. Anyway, I just briefly stop about the discussion of Turing award and Turing, etc. will come later on, but only thing I tell you that Turing was a great mathematician, a computer scientist, and a technologist also, who made significant contribution to the discipline of computer science. Friends, now we will like to know what ultimately is artificial intelligence, and then afterwards we will discuss why artificial intelligence is required. So first of all, we will discuss some definitions, or rather definitions of artificial intelligence by the pioneers in the discipline of artificial intelligence. Alain Reich is one of the well-known authors of books on artificial intelligence. His book Artificial Intelligence, along with Knight, is very well known and is followed as a text in most of the universities all over the world. She says about what artificial intelligence is. For this purpose, let us have a look at the slides. The slide says, AI is the study of making computers do things at which at the moment people are better. So, what we can say, that AI is the study of making or solving those problems which at the time being are solved better by human beings as compared to the computer systems. There are a number of things. We can sense a situation just in a fraction of a second. However, the computer may take a very long time. Even it is said that a 5-year-old child is much more intelligent in a number of aspects than the state-of-art computer system. So there are still domains, though by and by computer is able to do or is able to solve more and more problems better and faster than the human beings, but still there are a number of problem domains in which the problems are easily solvable or better and faster solvable by the human beings as compared to the computer systems. Now this definition definitely raises a question that first of all we investigate what are those domains in which the human beings are better than computer systems, and which are the domains in which the computer systems have surpassed the human beings. Because then and only then we can say what is the subject matter of artificial intelligence, because subject matter of artificial intelligence is concerned with those domains about the problems of which human beings are still better than computer systems. So friends, now next we'll look at those domains or those skills in which the computer systems are better than human beings, and then we look up on those domains or those skills in which the human beings are still better than the computer systems. So first of all, please look at the next slide and you'll find out that the computers are much better than the human beings, at least in numerical computation, in information storage and repetitive operations. Friends, I elaborate each of these separately. Numerical computations. What do you mean by numerical computation? You give to a computer system thousands of numbers, each of thousands of digits, and you just give a program of addition to the computer system, It may not be a matter of a second even that all the numbers, which may be thousands in number, each of thousands of digits, the answer, the addition or multiplication or division, etc., may come out in a fraction of a second. What we can say, that in respect of numerical computations, the computer systems have far surpassed the human skills. Then I mentioned that information storage. Now it is very well known. A full library can be stored on a disk, or at least very large books, at least of thousands and thousands of pages. The content of those books can be stored in a very small disk, which can be handled on our palm. So we know that in respect of information storage, the human mind is no comparison as compared to the computer system storage devices. Then repetitive operations. Friends, if you have a formula to calculate the salary of an employee, and you are required to calculate the salary of, say, thousands and thousands of employees of a particular corporate firm. Now after some time we get bored. That is, repetitive operations after some times become uninteresting for us, the human beings. However, the machine will cherish it, if cherish is the right word for a computer system. Give it any number of repetitions, there won't be any fatigue on the part of the computer system. So friends, at least it is known that in respect of numerical computations, in respect of information storage, in respect of repetitive operations, the computer systems are much better than the human beings. Then what are those domains in which the human beings are better than computer systems? Because as Alain Rich says, those are the domains which are of interest to the artificial intelligence people, which are of interest to the community of artificial intelligence people. So let us have a look at what are those domains in which human beings are still better than the computer systems. Please look at this next slide. Common sense or judgment based reasoning. Please look at the slide. This slide gives a few examples of the problem domains or the skills for which the human beings are better than computer systems. For example, whenever a problem involves common sense or judgment, for example, like crossing a road, please try to understand. If a computer is asked how to make a man cross or a human being cross a road in which thousands of vehicles are flying at a very fast rate, what probably will be the line of thought or the steps which a computer system may be required to take in order to make a human being successfully cross a road? Maybe something like that. That it notes the position of the human being, the beginning, initial position and the final position, and the line which joins these two, final destination and initial position. It may find the distance of the various vehicles which are moving in the direction of the person who is required to cross the road, and then it may also be required to find out the speeds also. And in the process, S is equal to ut plus half at square or something like that formula is applied in order to find out how much time those vehicles which are moving at different speeds may be taking over the human being when he is or she is at some point on the road. This is a sort of algorithmic method. However, how many of we human beings take this type of sequence of steps in order to cross a road? Nobody. How we are able to successfully cross the road? Every day thousands and thousands of people cross the road, even in such a big busy city like Delhi, and successfully. Of course, one or two hits may be there, but one or two hits as compared to millions of people who cross the road may be negligible. How we do? We just look at the total scenario of the road, and then we just on the basis of judgment, we see that now the various vehicles are distant enough not to hit, and we start crossing the road, and generally we are successful in crossing the road. What I want to emphasize in this particular case is judgment. Judgment is something which does not involve too much of computation, too much of calculations like s is equal to ut plus half at square or something like that. This is called judgment. When we look at the sky, we don't find out what percentage of clouds are there in the sky, say 39.87%. No, nothing like that. We just see that there are enough clouds or not enough clouds to bring rain or not to bring rain. Then we see that we know a number of other things also. For example, when we throw a plate up, naturally we know from our past experience that it will come down. So whatever thing is thrown up comes down. This type of common sense reasoning or knowledge helps us in solving a number of problems which when attempted with a computer system may require very large amount of computation, which may not be possible for a modern day computer systems to accomplish within reasonable amount of time. So these are some of the domains. In addition to these domains, you know, language understanding, speech, scene situation understanding, the human beings are still very good. Let us have an example how human beings are better than the computer systems. But before that, we'll like to have a look at another definition, which is by Buchanan and Shortleff. Please read the definition. So friends, what Reich has said, Reich looked at the domain of AI from one perspective which I mentioned, that it deals with those problem domains in which human beings are better than the computer systems. Friends, this definition has a number of problems. As we'll come later on with the discussion, because this means as more and more domains come under the purview of the computer systems, in the sense that computers become better than human beings, this is a self-shrinking discipline in that sense, that as more and more domains human beings become less efficient as compared to computer system, that particular domain is excluded from the domain of study of artificial intelligence. So in view of this definition, deficiency in the definition, we'll discuss another definition which is again by Buchanan and Shortleff, who are very well known computer scientists. Please look at the definition given by Shortleff at the slides. AI is that branch of computer science that deals with symbolic rather than numeric processing and non-algorithmic methods, including the rules of thumb or heuristics instead of algorithms, as techniques for solving problems. Friends, this definition raises the question of distinction between pair of concepts, namely symbolic versus numeric and non-algorithmic versus algorithms. I may say a few words first about algorithmic versus non-algorithm. Friends, algorithms, as algorithms may be said to, the study of algorithms may be said to be the focal point of whole of computer science, as I have discussed in many of my previous lectures. Just briefly I can say an algorithm is a systematic method in which a sequence of steps are mentioned. Each step is takes finite amount of time, etc., etc., which has a beginning and etc. So mainly algorithm can be thought of as a method, special method, in which there are a number of sequence of instructions and each instruction can be executed in finite amount of time. So what is non-algorithm? In non-algorithmic methods, we may not have a definite sequence of steps. just on the basis of exploitation of knowledge. As I mentioned, in the case of crossing a road, no systematic method is followed, neither can be followed. That is very important, because if we start following a specific sequence of instructions in order to cross a road, we may not be able to cross the road ever. Because I told you one of the sequence of instructions may be something like that. Find out the distances of the various moving vehicles, which is in itself very difficult. Find out the speeds of the various moving vehicles, which is again almost impossible. Then you apply the formula S is equal to ut plus half at square or some other similar formula. And then you find out or move in such a way that you are able to avoid the various vehicles. It is a very cumbersome task. It is not a systematic way of crossing a road when a human being crosses the road just by having an overview of the roads, various the situation of the various cars etc., without actually measuring the distance. So this is what is meant by the difference between algorithmic and non-algorithmic. Essentially, I don't say that this is the complete statement of difference between algorithmic and non-algorithmic. Rather, I am saying briefly you can have an idea. In algorithmic method, we must have a sequence of steps. However, in non-algorithmic method, you may have just a judgment. Just an overall situation is in your mind without actual calculations. Now, the next is very important distinction, which Buchanan and Shortleaf have mentioned, that artificial intelligence deals with symbolic computations than numeric computations. Friends, what do you mean by symbolic and numeric? And why symbolic is so different from numeric? So first of all, we will discuss what is symbolic and what is numeric and non-numeric, symbolic and numeric. Friends, we know 1, 2, 3, 4 etc., the various numbers, even the fraction 128.3 etc. or 4 by 7, all these are numbers. But you will be surprised. Sometimes 128 may not be a number. Sometimes ABE may be a number. Please try to understand. I am saying sometimes 128 may not be a number. And sometimes ABE may be a number. What is meant by a number and what is meant by a non-numeric symbol? Friends, when we say the house number 128, the next house number is 129. Can you find out the sum of the two house numbers? We don't have any meaning of sum of two houses. Whatever is the property etc. or anything, we don't know. Similarly, you have bus route number 128. You have another bus route number 129. Or you have another bus route number, say 132. Is the bus route number 128 plus 132, which comes out to be, I think, 260. Is the bus route number 128 plus the bus route number 132 is equal to the bus route number 260? No. The bus route number 260 may be quite independent of the two routes, bus route number 128 and bus route number 132. What do I mean by saying so? By this I mean to say is that in this particular case 128 and 132 are not numbers in the sense that the operation of plus minus multiplication etc. cannot be applied in this particular case. So, and on the other hand, I have said that ABE may be a number. Friends, what your dictionary does, dictionary puts all the words in lexicographic ordering. All the words starting with A precede all the words starting with C, and all the words starting with C precede all the words starting with CF. There is an order within the words of English language when written in a dictionary. So what a dictionary does, the dictionary numericalizes, if there is a word like numericalizes the English words, in the sense it puts an order between them. Even you know ABE may be a hexadecimal number. So when there is an order between the words of a language or any sequence of letters, sequences of letters, then they may become numbers or at least acquire numeric sense. So what is the essence of whole of this discussion about numbers and symbols? The essence of the discussion about numbers and symbols is that when a sequence of letters can be thought of in some arrangement of preceding and following, then those sequences of letters may constitute a sort of number system. However, even when the digits like root number 128 and root number 132, etc., in that case, though apparently 128 and 132 are numbers, but they are actually not in the numerical sense. To further emphasize the distinction between symbols and numbers is that it is the context which decides when a sequence of letters is actually a number or not. So Bukhanin says that when a sequence of letters, that is rather a sequence of words, does not have any predetermined numerical order, then they are symbolic, and artificial intelligence is about symbolic processing. What do you mean by symbolic processing? In numeric processing, what we do? For example, we have got thousands of employees, we know their salaries, we know the rules of income tax calculation, etc. Those rules are fed into the machine, and the income tax payable by each employee is found out. In the process of finding out the income tax for the various employees, what operations are executed by the machine are generally plus, minus, multiplication, division, etc. So this type of computation, in which plus, minus, multiplication, division, etc. are dominant operations, we call it is numeric processing. However, when we have this type of reasoning, that we generally what we say or ruminate or we discuss amongst ourselves, if it is cloudy, it may rain, and if it rains, then we should have an umbrella. So now it is cloudy, should we take umbrella or not? Now in this type of reasoning, nowhere you can apply the operations of plus, minus, multiplication, etc. You have to apply different type of operations in order to solve a problem with the help of computers if you are required to. So what I mean to say, in everyday life, the problems which we are mainly concerned are not of the type of addition, multiplication, division, rather this type of reasoning. So in order to solve this type of problems involving this type of reasonings, we have to have some different type of operations which are different from numeric operations. So I hope that you must be clear about that what artificial intelligence is according to Bukhanin and Shortleaf, that when the dominant operations are non-numeric in the solution of a particular problem, then it is a field of artificial intelligence. However, if most of the operations are numerical type, then in that case it is not AI problem. And I have already mentioned that Shortleaf and Bukhanin also say that when you are applying not a systematic sequence of steps in order to solve problem, then it is again an AI problem. So this is the aspect or this is the way Shortleff and Bukhanin describe the discipline of artificial intelligence, when most of the knowledge of your domain is in symbolic form rather than numeric form, and when the technique which you use in solving the problems is non-algorithmic instead of step by step. This is what the Shortleff and Bukhanin think of the discipline of artificial intelligence. Please, before we go in much deeper discussion of the definitions which have been suggested by the leading personalities in artificial intelligence, for example, Alain Reich on one hand and Bukhanin and Shortleff, first of all we should think, what are the advantages when the problem domain is mainly numerical, and what are the weaknesses when the problem domain is mainly numeric. And on the other hand, we think of the weaknesses and strengths of the domains which are basically symbolic. So first of all, we look at the strengths and weaknesses of those problem domains which are basically numeric, that is, in which most of the problem elements can be expressed in terms of numbers and can be solved by using operations on numbers like plus, minus, multiplication and division. For this purpose, let us have a look at the slides. Advantage if the problem domain is numeric or quantity. What does this mean? Because as I mentioned, number even 1 to 8, 128 may not be a number, and even AB may be a number. So if the domain is having numbers, what is the advantage? You have very well defined operations like plus, how addition is done, how multiplication is done, how subtraction is done, etc. are well defined and are embedded as part of the software of the machine. So it is very good. But what is the problem with numeric domain? The main problem with the numeric domain is that it cannot express most of the everyday problems. For example, we are hungry. How to get tasty food? Now, no numeric sequence of or operations can explain this problem or solve this problem. What to talk of solving the problem, even cannot explain. So, what I mean to say, in everyday life, most of the time we are concerned with non-numeric problems, and the numeric domains cannot even express the problem under consideration. That is the limitation of the numeric domains. However, as I told you, that in case a problem can be expressed in terms of numbers and their operations, then it is really fantastic in the sense that the machine can execute it very fast. I took the example of computation of the income tax of the people whose salaries are known. If you have to calculate the income taxes of even millions of people, the machine will be able to do it very fast and accurately also. But I just now mentioned, not many problems can be expressed as problems of income tax type. On the other hand, what are the advantages and weaknesses of the symbolic representation? The advantage of symbolic representations is that they can express most of the many types of problems. For example, as I mentioned a number of problems just now, whether to take an umbrella or not, whether we have how to satisfy our hunger, etc. All these can be expressed reasonably well in a language like English, which is not numeric, which is mainly symbolic. But what is the problem? Why don't we express our problems in English and attempt to solve those problems? Because it is not understood, cannot be explicitly understood. For example, I say 4 men and 3 women can complete a work in 8 days. 5 men and 4 women can complete the same task in 4 days. Find how many days will be taken by 1 man and 1 woman. Now don't translate in terms of 5m plus 3w is equal to 8, etc. and try to solve the problem. It is almost impossible to solve the problem in that case. But once you explain or express in mathematical language of 5m plus 4w is equal to something and etc., etc., you will be able to do it in a fraction of a second. So friends, what I want to emphasize is that symbolic language can express the problems very easily. However, the problem is that the operations available for solving symbolically expressed problems are very few, which are not very well defined. So, each of the representational system, numeric and non-numeric symbolic representations have its own advantage and etc. Friends, we will continue our discussion in the second half of the basic concepts and basic ideas in artificial intelligence.